Good afternoon, everybody. We're taking a look at the winter weather outlook today, and for this coming winter. This is all part of the Winter Weather Awareness Week. This is the first time we've done this in Virginia, so hopefully folks have been taking a look at the website and some of the things. Today we're actually focusing on ice storms and you're kind of looking back at the ice event we had last February that for some folks, it was pretty devastating, knocked power out for some people for up to 2 weeks, brought down a lot of trees and things like that. So it was a pretty devastating event. So we've got a review of that on the webpage for today. And we look into some of the safety things, some of the preparation things that you can do if we do happen to get another ice storm this year. So, and that page will be there, and all the links and things like that will be there. So you can take a look at that as you have time. So what we want to take a look at today is kind of, what we're expecting for this coming winter. So we're going to take a look at a little bit of the climatology. What's normal? What is really, when we look at that snowfall and things like that, what is actually normal for this, for parts of Eastern Virginia, and Maryland and Northeast North Carolina. So we're kind of take a look at that climatology. We'll take a short look back at last year. We'll take a look and see how much, how much rain did we get, how much snow, things like that, just to kind of put it back in your mind as far as what winter last year actually was like. And then we're going to take a look ahead and we'll see what's actually driving the forecast for the upcoming winter this year. So let's go ahead and run to the first poll question here before we dive into the climatology. And we'll get a kind of a first question here for you guys.
All right, and I don't think you can see it, Eric, but I put up the first question there, basically asking, what is a normal seasonal snowfall amount for Richmond and Norfolk? See what folks. All right, looks like most folks are coming in. Yeah, this was pretty good. And actually, two of these answers are pretty close, so you really can't. Depending on how you do the rounding, it actually could be either one. 50%, which is most of the folks, responded that it was 8 inches in Richmond and 3 inches in Norfolk. And then really most of the rest of the group responded to 7 inches in Richmond and 4 in Norfolk. So really just kind of off by an inch there at each location. So the answer is actually the second one, which would be B, but it is 8 inches in Richmond and about 3 inches in Norfolk. So, but yeah, that second one and the fourth option were very, very close. So I think folks have a pretty good sense for how much snow we get around the region.
All right, thanks, Jeff. All right, so the graphic you have up here now, we're showing what is the average and median snowfall values for our area. And, you can see there's 2 images I have up here. One was the normals from 1981 to 2010. And now that we've had a full season through 2020, and we have all that data, we were able to redo the normals as the Weather Service does. We work in 30-year blocks. So now we've updated those normals to the 1991 to 2020 normals. And you can generally see across the board, especially for inland areas, that the snowfall total averages have dropped. Generally speaking, we've lost about an inch with the new normals for whether we're talking about the average or the median. Now, the difference between the two, averages, we're just taking everything together, we add it together, we divide by the total number of years, and that's what the number is. What the median is actually, if we take all 30 years worth of data, we put the amounts in order. We're taking the one that's smack dab in the middle, the one that's number 15, and that's giving us an idea of what is, from a occurrence perspective, what's actually in the middle. And you notice there is a little bit of a difference, and part of that difference is because when we do have pretty snowy years here, sometimes we can have quite a bit. So sometimes those higher end values can nudge your quote unquote average up. But sometimes that average value actually ends up being, something we only see, 1 out of every 4 years, just because, if you have a couple big events in there, it can push that number up a little bit. So a lot of times, at least from in the office, when we're looking at things, we tend to look a little bit more at those median values, because that tells us to be a little bit more of what's actually kind of more 50-50 as far as right in the area. But generally speaking, even those values, we're generally within an inch to, an inch and a half difference between the average value and the median value. So it just kind of helps give you a little bit of an idea. So, again, we've seen, like I said, we've seen the change occur a little bit. The other thing that, you can notice is that the way that we've kind of got it shaded here, you get from kind of the Wakefield office moving south and east, generally speaking, the median value is going to be less than 6 inches in a year. you get to the far northwest, so you should start heading up into the Piedmont, up in Louisa, and then we start looking at 12 inches or more per year. So it does give you a kind of pretty good idea spread-wise of what we can expect on a normal year from snowfall across the area. All right, so I got a couple. We're going to look here at Richmond and Norfolk, just to kind of get an idea of kind of where we've been over the last 5-6 years as we go through this graphic. And what we've done here is we've taken it by percentile, and this gets us a little bit more into that, looking at values from a median perspective. So, 10% of the time we should expect to see 1.3 inches of snow or less in a year. And 10% of the time we should expect to see 21 inches or more per year. And when we went back over looking at the entire 40-year period, because this graphic's looking at 40 years from the winter of 81 up through 20 through 21 last year, there were actually 5 years that we had snow totals over 21 inches. A lot of those occurred in the 80s, 1982, 1983, 1987 were 3 of those years. The only time since we've turned the century and gotten to the 2000s, which was 2010, that we saw more than 21 inches at Richmond. At the same time, there have been 5 years that we've had totals under 1.3 inches. So the last one of those was in 2008. So it's been a while since we've had a season that had only 1.3 inches of snow or less. So, but granted, when we're looking at, from a statistical standpoint, those numbers really fit in very well with this graphic as far as where the 90th and 10th percentiles in. And that gives us a pretty good confidence in the median value at 8.6. So if we start looking at over the last, say, 7-8 winters, look at the number of times we were up into this upper range. At least 5 times in the last 8 years, we've been in that upper range. And so you can see sometimes how, from a variability standpoint, it doesn't take a whole lot necessarily to get into the higher end, but, we do get those values quite a bit. So especially I'm thinking in the 2018, 2019 winter for the city, and these snowfall measurements are, at the airport in Richmond. So take those with a little bit of, you got to understand that downtown and areas just to the west of town, probably have seen a little bit more. But the bulk of that snow in the 2018-2019 season came in one storm on December 9th. So there was probably close to a foot of snow on that one event. So sometimes the higher numbers can skew a little bit, because if you do happen to have one really good event, a lot of times you can get to those high numbers just with one storm. So there is a lot of variability year to year. Sometimes it's, smaller events where you have a couple inches here, a couple inches there. You have more of those to add up to the total. And sometimes it's just you happen to get the one big event that can push your values up. So just kind of gives you a little bit of an indication that, there is quite a bit of variability as far as what we see snowfall wise. And when we go to looking at Norfolk, Norfolk's got a lot of the same type of situations from a variability standpoint. You can see, we've got several years where it was very high like Richmond, and then there were other years where it was much less. So the 2018-2019 year we were just talking about at Richmond that had, over 13 inches and was up above the 70th percentile. The same time that year, Norfolk had 1/10 of an inch. So it was, all the way down into the, less than the 20th percentile, almost down to the 10th percentile. And there, it's the same season. So you can see there is a lot of variability in the area that we deal with. And a lot of it has to do with kind of sometimes, where the warm air gets to. So a lot of times if the ocean air is able to get in and keeps us warmer, we tend not to see snow. So sometimes that rain snow line can be pretty fine dividing line between the haves and the have-nots when it comes to snowfall. All right, so last year we did bounce back and Norfolk got up to about 3 inches, but again, most of that came in one snowstorm in January. So, again, with the values where they are, sometimes just having a one significant system can really drive your entire season as far as the numbers go. All right, so let's take a look back at last year, because last year, and so what we've got here on this graphic, when we're looking at last year's, we can see, in this one, we're looking at the observed precip. We're seeing how much precipitation fell. And the image that's on the left-hand side is actually the forecast from last year for the winter season, for the December, January, February forecast from the Climate Prediction Center. And if you notice in this forecast here, they were showing For chances of precipitation, either equal chances, and equal chances means that from a statistical standpoint, there's an even chance of seeing normal, below normal, or above normal. So there's really not a forecast that's actually being made there, because that means from a statistical standpoint, they can't differentiate one way or the other. There's not a signal that will help them drive the forecast to say it's going to be above or below normal. But part of the area was actually had a slightly better chance of being below normal, and that was really, really kind of the southeastern part of our forecast area. So you're talking about, South Central Virginia over to the Tidewater, parts of the Eastern Shore, and down in Northeast North Carolina. So you had a slightly better chance of looking at below normal, and that's where, as we look at Norfolk was definitely more into that. Richmond was kind of right on the borderline as far as the equal chances go to below normal. But when we start looking at these values, especially if we look at the winter totals of precipitation from December through February, we were 6 inches above normal last year. So in my mind, the forecast that we had there didn't necessarily verify very well, because we were still in a wet pattern. We'd been in a wet pattern most of the late summer last year, and that wet pattern continued well into the winter months. It wasn't until March that we got back to about normal as far as the precipitation went. So for that whole winter season, we were above normal precipitation. So looking at that climate forecast probably didn't necessarily verify that well last year. And last year, we were dealing with we were dealing with the La Nina. That was part of the driving force behind the forecast last year. So we can keep that in mind as we move further ahead and we look at the outlook for later this year. So the other thing to keep an eye on here, as you can see from a snowfall perspective, we're talking, we're pretty close to normal overall, especially for the winter months. We were 0.7 of an inch, quote unquote, below normal, but from a statistical standpoint, that's basically near normal. All right, when we look at the temperatures for last year, notice the temperature forecast. There was no doubt what they were forecasting temperature-wise. They were forecasting above normal temperatures. There's no doubt, no matter where you were in our forecast area, it was above normal. And in some cases, they were getting, definitely getting, between 40 and 50% chance of being above normal. So they were getting statistically, into the side of being warmer than normal. And if you'll notice in the temperatures for the winter months, we weren't there. We were actually 0.8 of a degree below normal. So actually, you're actually, almost 1 full degree below normal over 3 months, which is actually pretty significant. And a lot of that was driven by the month of February. February was much colder than normal. We were 2 to 2.4 degrees below normal. But when you average it out through the whole year, through the whole winter season, generally speaking, we were almost a full degree. Now, if you look at the period from November to March, you take the 2 surrounding months, all of a sudden it changes, and now we're actually slightly warmer than normal. So, I think that's one of those things to kind of consider. So sometimes your view of a season can be skewed a little bit based upon how you start and how you end. But looking at the 3-month winter period, we were definitely below normal temperature-wise, which again goes against what was in the outlook and the forecast for last year. All right, so taking a look at Norfolk. Norfolk, again, precip-wise, we were expected to be below normal, and even there, again, we're 5 degrees above normal for the winter months, December through February. So again, forecast not necessarily matching what the outcome was. So, considering we were supposed to be in La Nina, and La Nina usually tends to lead to drier than normal conditions, we didn't necessarily get that. So, but when we look at, there's a couple other slides coming up that we'll take a look at here. And when we see those will give you a little bit more indication as far as kind of how La Nina plays out in this pattern. Okay. All right, Jeff, I think we need to go to poll number 2 at this point.
Okay, I'll toss it out there. Yeah, so this is a little bit different, kind of talking about, you personally, when do you start to get excited about, the snowfall? So, and maybe when does it try to impact your decisions, whether it's a schooling decision, with kids coming and going to school, whether it's your own work, whether you're going to try to maybe stay home. Does any snow kind of start to mess up your plans? If you're forecasted to get 1 to 2 inches, 3 to 4, 4 to 6, or you're one of those that we could have a blizzard and you're going to go out no matter what. So just kind of get a sense for how much snow really starts to cause you issues and you personal concerns with you and your family. So let folks come in here. All right. I tell you, by far, the real winner here is the 3 to 4 inches. And I'd say I probably have to agree. That's where you really start seeing maybe some good accumulation on the roads, depending on temperatures. And so, overwhelmingly, 40% of you all voted for that 3 to 4 inches. And that actually fits well with our warnings and advisories. We issue our winter weather advisories and winter storm warnings. I'm right about winter storm warnings, excuse me, right about that 3 to 4 inches of accumulation. The next category was really almost tied between 1 to 2 inches, which is our winter weather advisory criteria. So if we're expecting about an inch or two of snowfall, we issue winter weather advisories. When we get 3 or 4 inches, we're issuing winter storm warnings. So,
but we're going to move now into the kind of the forecast realm of what we can expect for this year. And first thing we're going to take a look is, when they're talking about how they make these forecasts, what different things are they looking at? So the Climate Prediction Center in DC is the one who's making these forecasts. So that's something they do all year round. They make outlooks. They make outlooks in 3-month intervals every month for 12 months. So you can always find a 3-month outlook on the Climate Prediction Center's page for the 3-month period that you're looking for. So this time of the year, we're always pulling the December, January, February timeframe because that is the quote-unquote meteorological winter. So those are the 3 months that we're looking at. And the things some of the things we might be looking at here would be the ENSO cycle or the El Nino and the Southern Oscillation. That is, kind of one of the driving forces, and it has to deal with the coolness or the heat in the ocean waters in the Central Pacific. And we'll show a little bit in here where that plays into effect. There's also some other oscillations, the North Atlantic Oscillation, the Arctic Oscillation. The thing with those two oscillations is, we can't really forecast with them beyond maybe a couple week, maybe to a month period. So when you're trying to do a 3-month forecast, we don't really have great confidence and great ability to forecast how those are going to evolve beyond that kind of 2 to 4 week period. So, they have a little bit of an impact. The Madden-Julian Oscillation is another one, another kind of global type of pattern that gets in. And it's got about a 30 to 45 day cycle that it goes through. So it would be about half the time period, a third to a half of the time period. And then, you got the Pacific Decadal Oscillation. They also look at the fall monthly trends. They look at what's been happening because a lot of times what's happening in the fall bleeds into the winter. It doesn't necessarily just stop because the winter begins. And then there's a lot of other research and analogs to look back at previous years, what has the previous year done, things like that. So, but those 3 elements right there are really probably the 3 biggest as far as going into, as far as the oscillations go that go into the making of the forecast. All right, so we're going to look at El Nino and La Nina right now, just kind of following up with the poll question. And when we're looking at that, we're looking at what the anomaly is as far as the sea surface temperatures in the Central Pacific. So we're looking at whether they're above normal or below normal being the driving factor. And these do have, short-term impacts across the U.S. as far as the weather goes. It affects the storm track and things of that nature. And the thing is, the stronger the anomaly, usually the more predictable the atmospheric response is. So, and just like in the question that we just polled there, 24 times we've seen this. So it tends to be pretty well split between El Nino, which is the phase where it's warmer than normal in the Pacific, La Nina when it's colder, and then the neutral phase is actually kind of of the 3 is actually the lowest. So, but again, generally speaking, you're pretty close there at 25, 24, 22. And for this coming year, La Nina is expected to prevail again, just like it did last year in the winter of 2020 through 21. All right, so when we're looking at the current status, you can see here in the graphic, the one that's boxed in is what we call the Nino 3.4 region. So it's kind of the demarcation area in the Central Pacific. That's kind of the combination of 2 areas. And you can see how, we were colder than normal last year. We came out of it in spring, actually got to the point where we're actually just starting to creep above normal in midsummer with the sea surface temperatures. And then all of a sudden things started to drop off again. And once we got to mid-September, they really dropped off pretty hard. So we're getting now back to the point where we're in a fairly, probably in a moderate type of La Nina pattern. So what does that mean for us across the ocean? This kind of gives you a typical weather pattern when we're dealing with La Nina. So the Pacific jets farther north, It's climbing up into western parts of the U.S. and into kind of southwestern parts of Canada. So that's where the moisture is going from the Pacific. We're getting some cool air intrusions from Alaska that are diving in through the upper Midwest and through the Great Lakes, but they're not making it down into the southeastern U.S. So the thing you can see here, and if you remember the forecast that they had for last winter, the forecast they had for last winter of warmer temperatures across the south and up the eastern seaboard, and the kind of the wet signal across the Ohio Valley, that was the typical La Nina pattern. So if we're expecting La Nina to develop, this is the pattern we should be seeing. And in some respects, that's kind of what we're seeing right now weather-wise, because we've been very dry this fall. And actually from a temperature standpoint, October was pretty warm. We got a little bit cooler in November, but October was pretty warm. And right now, look at today, I mean, we're pushing temperatures up into the 60s today. So we're definitely kind of, La Nina is kind of showing its hand right now. Now, when you look at some of the different values here, this puts all the different winters as far as snowfall and temperature for the city of Richmond together over kind of the last 70 years. And you can see last year's are highlighted in yellow. So you can see from a snowfall perspective in La Nina, we were just a little bit below what the normal snowfall was in La Ninas, and we were actually a little bit below temperature-wise what you would expect. So, generally speaking, last year didn't necessarily fit the bill for what we expect with a typical La Nina. So some of that has to do with what are those other oscillations doing? How do they impact things? So sometimes some of those more, local northern hemisphere type circulations can overwhelm just a signal. So it's not always a one-to-one type of relationship between La Nina and our weather pattern. So you can see the variability in there. Sometimes we're warmer than that. Sometimes we've been much colder. And we've even had some winters where we've had quite a bit of snow. Even though you have one of these, you have El Nino or La Nina, they're not always, it's not always a perfect relationship. It's not always a one-to-one correlation. Last year, when you look at Norfolk, again, snowfall-wise, we were definitely below normal from a snowfall perspective, but temperatures were pretty much right in line with what you would expect with La Nina. So again, there's variability there, and that's one of those things that from a long-range plan, you have to try to then, as you're trying to forecast, kind of take some of that variability in, because even with having, a warmer than normal type of season, you can still have good snowstorms and things like that, because the pattern does break down in very short sections of it. So, because remember, this is a 3-month forecast that's averaged over that entire time period. So, taking a look, kind of what's helping to drive the forecast, knowing La Nina is in play, and we're dealing with the back-to-back, from a statistical standpoint. This map shows the number of times that we've had that we've had La Nina winters that were warmer than normal. And notice across most of our area, we're talking somewhere between 10 to 12 times out of those 16 times that we've seen this back-to-back La Nina pattern, 10 to 12 times we've seen the temperatures be above normal. So that gives us a pretty good indication that the warmer than normal, temperatures can probably be expected. Statistically, it says it should be. So you got a little bit of confidence there. Now we go to the precipitation. It's even a little bit stronger in that fact that the number of times that we had a wetter La Nina after with the back-to-back one, notice it's only one or two, kind of 1, 2, 3 times that we've seen that type of a pattern across Eastern Virginia, portions of the Delmarva and Northeast North Carolina. So, we should not be expecting to see an above normal from precipitation this winter. That's what the climatology tells us. That's what it shows here. Last year we went against the trend with La Nina to be wetter than normal. But this year, with the back-to-back, it's only happened 2 or 3 times when we've had this pattern. So you're talking less than 20% chance of it being above normal. So when we look at the actual forecast, here it is. From a temperature perspective, definitely looking at being above normal. That seems to fit the pattern. It fits with what we're seeing going on right now in the trends, and it fits the overall pattern with La Nina. The temperature, the precipitation forecast that's on the right, you can see right now, they're calling equal chances. Maybe some of that has to do with the fact that last year, they were forecasting it to be drier, and we managed to actually be wetter. So maybe there's some influence from last year in the forecast. But if you look at the data we looked at on the map, from a statistical standpoint, there's probably only about a 20% chance of it being more of above normal. So the strong likelihood in my mind is that we're actually going to be probably a little bit more below normal based upon the historical trends and also kind of what we've seen this fall, where we've been for the last several months, we've been drier than normal. And right now, if you look at the drought monitor this morning, we've got quite a bit of areas designated to being in moderate to severe drought now across a good part of the mid-Atlantic states. So, that's kind of where our forecast is at this point. So you can see, now remember, even within this, there's variability, because remember, these are 3-month averages. So within that variability, that doesn't mean we still can't have a good snowstorm or a good cold outbreak, because those do happen even within. But when we start averaging across the 3-month period, generally speaking, we should be looking at, a pretty good chance of seeing above normal temperatures and below normal precipitation. So that's everything that we have for the outlook today. For the presentation, we can take any questions, Jeff, that have come in right now.
Okay, yeah, so what I can do is turn my camera back on here. And if folks want to send some questions in, or if they want to try to raise their hand, I'll see if I can unmute you if you want to try to come in and ask a question. Just kind of hang on here for a few minutes. I will just mention, all of our forecasts and warnings are on our website. What Derek's got it right here, just weather.gov/AKQ, or just go to weather.gov. It'll take you to the whole U.S. map, and then from there you can just click on whatever location for which you want to forecast. And we do have our winter weather awareness page up and running, so definitely look at that. It has the ice storm highlighted from last year with the really over 3 million people without power. Some folks without power for several weeks, especially across locations south and southwest of Richmond. But yeah, weather.gov, you can get our snow forecast, probabilistic snow forecast. When you're interested in knowing what's the chance I'm getting 3 inches of snow versus 6 inches of snow, all that information is on our website. So a lot more information here than what there was several years ago, where we'll give you our best guess of what we think is going to happen snowfall wise. So maybe we're forecasting 2 to 3 inches, but we all know there's a chance it could be 4, maybe even a chance it could be 6 inches. And so this gives you an idea of what those chances might be, even though we're maybe forecasting 2 to 3. And of course, on our main webpage, which Eric will show you here in a second, he backs out to our main site. If you just want to get quick and dirty your local forecast, just interact with the map. Just click on whatever location you're interested in, and that'll take you to the local forecast for your vicinity. And from that point, you'll see any watches and warnings in effect. You'll see the actual forecast there. And as you scroll down towards the bottom, if you really want to get into it, you can see the hour-by-hour weather graphs. So it gives you an idea of what the temperature is going to be every hour, the wind speed, and if there's any kind of rain, thunderstorm, snow, freezing rain, sleet, it'll give you the idea of the exact timing of that, and that goes out through 7 days. So a lot of great resources on our website. And just start with weather.gov and just go to the Wakefield office and either click on the map, get your local forecast, or go down there and click on the snow icon, the snowflake icon on our main page. So really good information.